YouTubers, and welcome back to class. Today we are going to be learning about proportions. So our first step to learning about proportions is to recall the definition of it. So proportions are the comparison of a part to its whole. So when using a proportion, you can see the part to its whole. So there are three ways to write this. So we have word form. So when we use word form, we're using the word to. So we're going to say the part to the whole. So if we say we have 3 slices out of 6 slices of a pie, we would say the part of 3 to all 6 slices. So moving on, we also have fraction form, which we see most often. So when we see fraction form, we have part over whole. So again, let's use the pie. We have 3 slices of a pie, which is our part, and 6 slices total, which is our whole. We would say we had 3 over 6. And our last one is colon form. These are where there are 2 dots, one above the other, in a straight vertical line. And when doing that, we say part whole. So part colon whole. And again, using the pie, we have 3 parts of a 6-part pie. So those are our 3 ways we can write it. And again, proportions definition is the comparison of a part to its whole. So we're going to work with some examples. Something that happens often with proportions is that we are asked to find the whole, the part, if we adjust it. So if we find an equal value to it. So when working with it, we have to make sure that these 2 proportions that are in fraction form, as we can see here, are gonna be equal to each other, hence the equal sign. So whatever we have that represents this x has to make these 2 proportions equivalent to each other. So there are multiple ways we can do this. The first way is looking at the numerators and the denominators. And so we can see here that we have both numerators and we're looking for the denominator x. So we ask ourselves, what do we do to 8 to get to 80? And we're not looking at addition or subtraction, we're looking at multiplication or division. So we can multiply 8 by some number to get 80, or do we divide 8 by some number to get 80? Well, by looking at it, we can tell that 80 is bigger than 8. So we're going to have to multiply 8 by something. And if we think through and remember our multiplication facts, we know that 8 times 10 is going to give us 80. Now, whatever we do to the top, we have to do to the bottom to keep them equivalent to each other. So we would also times that 9 by 10. And when we do that, we're going to get that x equals 9 times 10, which is going to be 90. So we find that the x, to keep these 2 proportions equivalent to each other, is going to be 90. So now sometimes we get fractions and proportions that aren't simple. So we can see here, for example, that this 4 and this 17 are going to be the 2 numbers we use if we are going to use that above method. But it's not obvious what you can multiply or divide 4 to get 17, because we're looking for this x. So something that people use often is a little trick called cross multiplication. So you multiply this x by 17, and this 4 by the 8. So you multiply the numerators by the opposite's denominator and the denominator by the opposite's numerator. So when you do this, you're going to get 4 times 8. You're going to set that equal to 17 times x. So we can go ahead and multiply 4 times 8. We're going to get 32. And we are dropping that 17x because we haven't used it yet. And what's left is to undo this multiplication here. So to undo it, we have to divide again by 17, because that is the opposite of multiplication. That will undo multiplying by x by 17. And we do that on both sides, so 32 divided by 17 is going to give us 32/17 equals x. So we would simply replace x with 32/17 to get these proportions to be equal to each other. So we're going to move on. Another thing with proportions is it deals a lot with geometry. So whether we scale up or scale down a geometric figure, we do using proportions. So if you recall that first problem we did, where we multiplied the numerator and the denominator by 10, we can call that 10 our scale factor. So that is what we're multiplying or dividing by to scale a proportion. So if we look at these two images here, we see that this triangle is the same triangle as this one, but it's bigger. So if you shrunk down this EDF triangle, you'd get the ABC triangle. If you enlarged the ABC triangle, you'd get that EDF triangle. So to be able to scale or enlarge this ABC triangle, they multiplied each side by this 2 here. So that is what our scale factor is. So to find the length of each side, we're going to have to multiply the ABC triangle, each side, by 2 to find the lengths of each DEF triangle. So we're going to start by multiplying this 5 here by the 2. So we're going to get 5 times 2. When we multiply that out, we're going to get 10 units. So this DE length is going to be 10 units. So now we're going to move on to this BC here, which we know is the length EF with a scale factor of 2. So we can multiply 3 by 2. We're going to get 6 units. And then we have to find the last side length of this DEF, which is the length DF. And to find that, we have to take its corresponding side, AC, and multiply that by 2, or by our scale factor, so 6.5 times 2. And when we multiply 6.5 by 2, we get 13 units. So if you see, we just multiplied each side length by the scale factor to find its proportionally equal triangle. So sometimes we are given a problem where we not only need to find a side, but we also need to find the scale factor. Don't worry, it's a lot easier than it looks. So when we work on it, we want to stop and look at which sides are proportionally equal to each other. So we know that AB is proportionally equal to DE. We know that BC is proportionally equal to EF. And we know that AC is proportionally equal to DF. So when we find the scale factor, we need to look at the equivalent proportional sides. So what do we do to 7 to get 28? When we know we're multiplying, so when we stop and think about it, we have to figure out what are we multiplying 7 by to get 28. And to undo it, we can do divide by 7. So all that we have is that question mark, which is our scale factor. And when we divide 28 by 7, we get 4. So we know that we're multiplying 7 by 4 to get 28. And if we recall, when using scale factors, you multiply the original side by the scale factor to get 28. So our scale factor, in this case, in the case of AB to DE, is 4. Now we want to double check that. So again, we're going to double check with that BC to EF, which is the exact same. And again, we're going to do 7 times our scale factor, our question mark, is 28. And we divide, we're going to get the exact same thing of the scale factor equaling 4. So we know that our scale factor is 4. So we found our scale factor, and now we have to find our last step, which is our x units. How long is that DF? Well, we know that all the other sides of the original triangle creates the new one by a scale factor of 4. That should apply when scaling and enlarging the AC to the DF. So we are going to take 4.5 and multiply that by 4, which is our scale factor, to find x. So when we multiply 4.5 times 4, we get 18. So 18 is our DF side length. So that's what x is going to be equal to. So again, we're going to move on. Another way that you might see proportions is in word problems. So I want y'all to pause and go ahead on a piece of paper that you should be using for all your notes. Try this word problem out to find the equal proportion for what we're looking for. Okay, so by now I'm hoping you hit play because you've given it your best shot. So we're going to first dissect what the word problem is asking us. So it says that Preston is painting and combines blue and red paint. Preston first adds 4 teaspoons of blue and 3 teaspoons of red. When Preston runs out of paint, he realizes that he needs 3 times as much paint as he had in the first batch to finish painting. How much red and blue paint should he use to finish the painting? So we need to know how much paint of each color he's going to mix together to have enough paint to finish this painting he's doing. So we know that the original batch has 4 teaspoons of blue and 3 teaspoons of red. So we're going to say that he has 4 over 3 as our proportion. And then it says he needs 3 times as much. So that means we're going to need to find the proportion equivalent to 4/3 with a scale factor of 3. This 3 times as much tells us our scale factor. So we are going to have to multiply the numerator and the denominator by our scale factor. Of 3. So when we do this, we can multiply that 4 times 3 to get 12, and that 3 times 3 to get 9. And we're not simplifying in this case, because if we simplify, we're just going to get to that same original proportion. Now, that's the thing. Proportions are equivalent to each other, so you can simplify one to get the other. So in this case, we are asking for that unsimplified version when we're asking for proportions and how much we can get or we need at the end. So we know that at the end, he's going to need 12 teaspoons of blue paint and 9 teaspoons of red paint. So there we have it. That is how we find out how much paint he's going to need to finish his painting. Let's hope he has enough. But if you are still struggling, feel free to ask your teachers or to go over iExcel and the practice problems that are provided for you. And I hope to see y'all next time. Bye!